Hello and welcome to Unit 9 on impulse and momentum. In this first part, we are going to introduce the concept of momentum. And to begin with, we're going to think about Newton's second law. Now, you might remember that Newton's second law said that the net force acting on an object equaled the mass of the object multiplied by the acceleration. What I want to do is plug in the definition of acceleration here, with it being the change in velocity over time. Here I've written in the derivative form. And now I'm going to make an assumption that I can move the d by dt to the other side of the m. That means that the mass had to be constant in order to move in and out of the derivative. And now I'm going to make a definition that the quantity mv is something given by the letter p. And what is that letter p? P is the momentum. As you can see, it is a vector. Okay, momentum is a vector. Before we move on, I'm going to write one more form of this, that the net force multiplied by the differential time interval is the differential for momentum. So F net dt equals dp. So what is momentum? Momentum is the mass multiplied by the velocity. Because velocity is a vector, momentum is a vector as well. The units of momentum are kilograms times meters divided by seconds. So now let's think about this for just a moment. We have a 2 kilogram object moving at 3 meters per second to the right. We want to know its momentum. Well, the momentum will be the mass times the velocity. The mass is 2 kilograms. The velocity is 3 meters per second. I'm just going to write it as a right. So that makes the momentum equal to 6 kilogram meters per second directed to the right. Would the momentum be the same if it were moving in the opposite direction? If it were moving in the opposite direction, then the momentum would be, again, mv, but that would be 2 kilograms times 3 meters per second to the left, giving a momentum of 6 kilogram meters per second to the left. So the magnitude of the momentum is the same, but the momentum is not because the direction is different. If I know the momentum of an object, let's say, for example, that it is 60 kilogram meters per second in the I hat direction plus 30 t squared kilogram meters per second in the j hat direction, then I can find the force. So we had that the force was dp dt. So taking the derivative of the 16th term lands me at 6. The units will have to change to newtons. The derivative of 30t squared becomes 60t, again in newtons. And that allows me to move from momentum to force. This concludes this part of Unit 9.